Welcome to another Friday night restoration. Now this may be a very short project, or it could be an interesting project at the end of which we have a functioning TV. I really don't know. First, a little background on this set. A few months ago my friend and I came across an ad on Craigslist where a vintage electronics enthusiast was giving away some of his collection for free to a good home. Well, we headed over there, and I came back with, let's see, an Atwater Kent radio, an ICO 324 RF generator, a Mayfair reel-to-reel tape recorder, and this TV, and a few other odds and ends. I had them in the garage for a while, and I later got some more stuff, and this kind of got buried, and I actually completely forgot that I had it until a couple weeks ago when I was cleaning out the garage, and I came across it again. So I thought I'd bring it inside and take a look at it tonight. As near as I can make out, it's a model Y14P3. There are a bunch of sets in that family. Basically, they had different color cabinets. This is the most boring of the group, I think. Black body with an off-white front. There are other versions that are two-tone, like red and white, green and white, blue and white. Oh well. If I really wanted to, I suppose I could repaint it someday. Electrically, it's a pretty simple circuit. What I was most surprised to see is the power supply. Here it is. Because there's no voltage doubler. There's also no transformer, so it's a hot chassis set. But there's just one rectifier diode and then a filter capacitor, and that's it. So this set actually just runs on 125 volts DC. Most sets use a doubler and run on around 250 or 275. So curious design, they were able to make a TV run on that low voltage. Now the reason I said that this might be a very short video is that I have never looked at this set. I've never popped it open. I have no idea if this picture tube's any good, flyback's any good, or output transformer's any good, and so on. It's filthy. That's just how I got it. It had been stored in the kind of the corner of this guy's basement for a long time. So the first thing I want to do is grab a little 409 and some paper towels and clean it off, just so I don't get my hands all filthy working on this. So far, I think my favorite thing about this set is the knobs. Not a single one of these knobs is correct, based on the photos that I've seen, and they certainly don't match each other. There's the back side. Alright, and there's the model 14P3. Alright, so I'll clean this off, pop open this back, pull out my Sencor CR70, and let's check that picture tube, which is a 14RP4. I do not have any spares. If it's bad, like it has a bad filament, then that's the end of this project. Alright, that's looking a little more respectable now. There's the newer style Motorola logo. I'm not quite sure when that came into be, as opposed to the older Squiggle M Motorola logo. Side view. A few scuffs here and there, a little bit of rust starting to peek through, but overall it's not too bad. I already took off all of the screws on the back except one. I have not peeked inside yet then, so we'll both see this for the first time together. Alright, here goes, I think. That's filthy. The previous owner did have a bunch of cats, so there is cat hair on everything. I'll grab a flashlight and get the camera off the tripod so we can go poking around for a closer look. Okay, here's the tube charts. And here is the set. Got some nice cobwebs in there, along with lots of cat hair and dust and dirt. There's a metal chassis, and I believe uses point-to-point wiring on the other side of this metal chassis here. I think the tuner's copper plated. Thought that was rust at first, but no, I think it's copper plated. Alright, so looks like all the tubes are here. There's a flyback cage, already opened up a bit. A little rectifier tube up there. Flyback looks okay, just a little crack in the rubber insulation, but otherwise doesn't look fried or melted or anything. Awfully small though, look how dinky that thing is. Alright, so I'll pop that cap off the CRT and see if it's any good. I cleared away some of the dust, dirt, and debris, and I can see that this is a Motorola branded picture tube. Also notice that the interior of the cabinet is painted a nice shade of blue. Alright, so CR70 is hooked up. I've got the settings right for the 14RP4. So it's on. Filament. It is glowing. Might be hard to see with the floodlight on, but it is glowing. Alright, shorts. G1 shorts. Cut off. No cutoff at all. Let's see if we have any emissions. Well, I will let this sit for a while. I warned you it might be a short project. Could have an open G1, open grid. What'll happen when you've got no cutoff control, no emissions. So I'm going to double check my connections here. Yeah, looks good. Oh boy, that is dead. Alright, well, I will let this cook for a little while, maybe increase the filament voltage and see if I can coax some life out of this. It's been about 15 minutes and I still have absolutely zero. I think I might have misspoken a moment ago when I said that this is an indication of an open grid. What I meant to say was an open cathode, which means there's no way for electrons to flow through that gun. So, two things come to mind. Yeah, the cathode could be open or it could be a little bit gassy. That's what happened with 16GP4 tube I had not too long ago. What I want to do now is pop this chassis out so I can get a closer look at that picture tube and visually inspect it better. Because there is a trick to try to re-weld the cathode, but I need to get better access to the neck before I can even attempt that. It turns out that the chassis pulls out of the cabinet, but the CRT actually stays behind. These portable sets can be pretty tricky to dismantle. Luckily, I found some step-by-step instructions in this most often needed 1958 servicing information booklet. And I show you right here. Remove the back cover, remove the handle, remove control, the knobs rather. Disconnect the yoke and so on. And then you start sliding the chassis back towards the rear and you have to twist it and shimmy it a bit and eventually it does pop out. They also have instructions on how to remove the safety glass from the front, which I've also done. Nice and filthy and disgusting on the inside. I'll clean that out. Wondering if I get the set running. So here's a closer look at the chassis. Not a whole lot to it. There's the one selenium rectifier. This is the only electrolytic in the set. So there's the one rectifier. And there's an electrolytic, one section there, another section here. And there's a third section used in another circuit. I think all the parts are original. All the caps seem to be these white ceramic tube types. I think the interior is identical to a paper cap. It's a jelly roll of paper and foil, and they just happen to be in these ceramic tubes instead of sort of a wax cylinder. Here's a fusible resistor. It's intact, so whenever this set was last turned on, it was probably operational to some extent. The previous owner did imply that the set had worked last time he used it. Who knows? Looks like a dual selenium diode. I didn't realize the set used any. Yeah. It's for the horizontal sync circuit. I think it also has a diode for the video detector. Oh, there we go. So they really trimmed down the parts counter, so there aren't very many tubes in this. And that's because, well, they were able to use a few diodes at the time. The set is from around 1958, so silicon rectifiers were available. However, they did use a selenium here. Although if you contrast this to the Philco Town & Country from around 1961, that set did use silicon power rectifiers, not selenium. Alright, well, I'm going to set this aside for now and focus on removing this picture tube, which I believe comes out from the front. I can see some screws up there supplying tension to a metal band that's holding the picture tube in place. I managed to get the picture tube unmounted, and I cleaned it up a bit. Appears to be the original 14RP4. I've poked it back up to the Suncor. I inspected the base. I didn't see anything obvious other than a bit of a solder glob on this pin here. So maybe somebody was touching up these pins, or maybe it came out of the factory like that. Hard to say. So figure I elevated the filament voltage a bit, and I'll let this cook for a bit longer. Still no emissions. I inspected inside the elements here, and I didn't see anything obvious wrong. Like, I didn't see any leads broken off or anything. Still could be a loose connection though in the base. I don't know. Okay, I think we might be in business. I used a trick I've mentioned in other videos in which you put the Suncor into the manual to restore position and wait 60 seconds. What that does is it increases the filament voltage, I think to maybe 8 or 9 volts. Gets it glowing quite bright. You then flip over to remove G1 short. Before it cools down, you hold down the red button and you tap the neck of the CRT and look for a flash. It took me 3 tries. I got a flash each time, but it didn't seem to hold. But this time, it seems to be working alright. So I'm in the cutoff mode now, and it's very responsive. And if I check emissions, well into the good range. I'm going to let this thing cycle off and on a few times to make sure that weld's really going to hold. If you don't have a Suncor, I imagine the same trick will work just fine with other testers, as long as you've got a remove G1 short function and you can increase the filament voltage a bit. Life test is pretty good too. Alright, so I'm going to turn this off, turn it back on. What I'm concerned about is that several heating and cooling cycles may break the connection open again. Only a couple minutes passed and I saw the needle drop right back down to 0 without me having turned this off or on or anything, so we're going to give this another try. So what can happen is there are very fine leads that come from these external pins that go down into the neck of the CRT. And from getting knocked around, as I imagine this portable set had been, those little wires can break loose. The idea here is when you remove G1 short, it puts a few hundred volts on those elements, and if you give it a whack between the electrostatic attraction and you giving it a whack, you can get those elements close enough together that they will make contact, and then there's enough current that it can actually weld the contact back together. Oh, nice bright flash that time. But no emissions back. Alright, we'll just keep at it. One time I did this before successfully. I had to give it maybe 30 cycles of going through this till it finally really stuck, and that was a couple years ago, and the CRT still tests good to this day. So it is definitely possible to make this work. Alright, I've cycled the power about 4 times now and things are still looking good, so I'm going to move on to the rest of the set. Next up, I'm going to check all the tubes. So far all the tubes are testing just fine. Only one of them is an actual Motorola branded tube though, and that's the 12 DQ6 horizontal output tube. I like these realistic tubes, realistic lifetime tubes. They appear to have gold plated pins. Might be phosphor bronze or something, but might actually be gold plated too. Got one of them plugged in for testing right now. Yeah, tests just fine. I finished testing the tubes and I only found one weak tube. It was a 5U8. I dug up a replacement. I repopulated all the tubes. Now I'm going to move on to the electronics. One big filter cap down here. It's got 2 big filter caps in it. One 250 microfarad and one 200 microfarad. I dug up some replacements and they're both 220s. I figure replacing a 250 and a 200 with two 220s, that'll be close enough. And I'm over the original voltage spec. I think it was 160 volts or so, and I went with 250 volts. That'll be fine. So 2 of these guys in here, and there's a third section. I think it's 10 microfarads. I'll dig up another cap for that. There might still be some life left in this, or maybe I could reform it, but I'm not going to bother. I'll just pop it out. It's the only filter cap in here, so just clip these leads off, pop this can out. I'll tape up 3 caps together and just temporarily stick them in there. I'll replace this with a modern silicon diode with a resistor in series. I think I'll go with about 100 ohms to simulate the loss, and the selenium rectifier. And as far as the other caps, for sure I'm going to replace this guy. It's so charred I can't even read the number on it. I'm going to have to refer to the parts placement. And, maybe a couple others like this guy. And then I'm going to try powering it up. And if need be, I'll pop it out and replace the rest. Well, let me think about that. Let's see. So as I'm looking at this, I realize that most of these caps are actually ceramic. So why don't I just go ahead and shotgun this thing? I mean, what are we talking about? 1, 2, 3, 4, 5, 6, 7, 8. I think there's only 9 paper caps, so I'll just replace all of them. So 3 electrolytics, diode and resistor, and about 9 new paper caps. Then I'll put this back together and try powering it up. Okay, I finished recapping to the point where I want to try powering it up. Here's the 3 new electrolytics down here. And I had various new plastic film caps scattered around. Also discovered there were a couple old repairs. There's what looks like an orange drop cap down in there, and this guy, so I just left those alone. And I also did leave the original selenium rectifier in place. I've had fairly good luck with those lasting at least long enough to do a power-up test. In the end I will replace it, but I'm getting kind of anxious to try powering this setup, so I'm going to pop the picture tube in there and hook the yoke back up and so on and power this thing up. Okay, ready for a first power up. Now if you recall, the CRT is supposed to mount inside the cabinet, so I had to pack some stuff in around the base and on the neck to get it fairly secure and make sure it makes contact with this grounding strap. I've got it plugged into my isolation transformer, and I think we're good to go here. So, Variac is hot, and here comes the power. Do not see any tubes lighting up. Variac's up. Alright, I'm going to make sure that I've got solid connection on the AC cord. Okay, I checked the power cord for continuity through the AC connector there, through the power switch and so on, and we do have continuity, and we do have B+. It's been on the high side. It should only be about 125 volts, but the tubes aren't lit up, and if they were lit up and powered, they would draw some power from the B+ line and bring it down probably close to 125 volts. So what does that mean? Well, so if we look at the AC power, it goes through 2 branches. One goes through the fusistor to the rectifier and provides that 125, and that's what my meter's testing right now, so that part's good. The other side goes through a resistor, then all the tube filaments. So either that resistor could be bad, or somewhere we've got a break in the series string. I tested all the tubes in the CRT, and they're sure all tested good. Now, we could have a bad socket. One of these inductors could have corroded through. I had that problem in a Motorola set a while back. Could just have a loose tube, so I will investigate. So what I'll simply do is hook up my ohm meter to that point right there, and then start checking. I'll go through this resistor, and then this tube socket, and this, and this, and this, and this, until I finally lose continuity. Alright, with the aid of this tube chart and this diagram showing where all the filaments are connected together, I discovered that this tube right here was not firmly seated all the way down. So I'm going to do one final continuity check, then remount the picture tube and try firing this up again. Okay, it is time for yet another test. So, power's on, and I see the filaments are glowing this time. It's a very good sign. Everything's lighting up. I hear static. for a little bit of high voltage crackle. Woohoo! We have a raster. Alright. Trying to get that on camera better for you guys. That'll do for now. Let's see. It's good it's responding to the tuner. It's a very good sign. Do not have an antenna hooked up, so I was just hoping I might be able to pick up channel 6 a little bit. Well, it might be 6. A little bit of something it's trying to receive there, I think. I don't know. Awesome. Nice bright picture too, really bright raster. Alright, I'm going to hook up a signal source. See if we can get this set to actually display something and get some sound out of it. I'm going to give the cat antenna a try this time around. Okay, it's static. Ooh, that's promising. This is vertical hold, I believe. This brightness. This is contrast. Looks like horizontal's really out of whack. I noticed with my last video that this camera doesn't do too good on TV reception, so I hope this turns out. There's also a local distance switch on the back. I'm going to try changing that. It seemed to make it worse, maybe. Well, let's see. Here's the diagram. Okay, there's horizontal hold. You can need a special tool for that. Oh, no, I can just the potentiometer. Oh. And the height is completely stretched out. That's this control. Okay. Oh, hey. Darn near there. Well, there's some. So just a fine tuning a little bit. It's a Peter Sellers movie, I do believe. Oh, it's a shot in the dark, I do believe. I did a little bit more tweaking and switched some channels around. Now we've got She-Ra, bad 80s cartoon. It's not playing perfectly, but it's not bad for a few hours work, if you ask me.
Did you notice when he came out, his voice filled this room? I did notice it. The room got a little crowded. I didn't realize. You know, Mr. Crampton, it's hard.
Alright, well, that's going to do it for tonight. I won't call this a complete restoration, but I think it's pretty respectable for one night on a TV that was pretty beat up. So I hope you enjoyed this look at a Motorola Y14P3, and I'll do a follow-up video on this in the near future.
I realize you wouldn't be interested in a part of the play. It would. Well, I certainly wish you would consider it. Well,